What if I told you that all around you, right now, there's an invisible ballet going on? A performance on a scale so tiny it's almost impossible to imagine, but so powerful that it literally shapes our entire world. Well, today, we're going to pull back the curtain on this hidden symphony of chemical reactions.
Seriously, think about that for a second. Rising bread, the battery powering your phone, the very air you're breathing. They couldn't be more different, right? They almost feel like different kinds of magic. But it turns out, they all share one fundamental, incredible secret.
And there it is. The secret is chemical reactions. Every single second, billions upon billions of tiny particles are performing this intricate dance, swapping partners, creating new things, and powering our reality. So let's get a front row seat to this atomic ballet.
Okay, so every great performance needs its stars, right? And in our chemical symphony, the stars of the show are the atoms, the molecules, and, of course, the bonds that hold them all together. It's time to meet our principal dancers.
First up, we've got the atom. Just think of an atom as the solo performer, the fundamental dancer in this whole ballroom. It's the smallest possible piece of an element you can have, like one single atom of gold or one single atom of oxygen. They are the building blocks for, well, absolutely everything.
But solo dancers don't usually stay solo for long. When atoms team up, when they join hands, they form a molecule. You can picture these as little dance troupes. Like when two hydrogen atoms grab onto an oxygen atom and they start doing the famous water routine together.
So, what's holding these little dance troupes together? That's where chemical bonds come in. They're these invisible but super powerful forces that link the atoms to each other. And this is the key. During a chemical reaction, it's these exact bonds that break and then reform, letting our dancers switch partners and create totally new dance numbers.
So we've got our dancers. We know how they're connected, but what actually gets them to start dancing in the first place? What kicks off the whole performance? Well, the answer is energy. It's the fuel for the dance, the spark that sets the whole stage on fire, sometimes literally.
You see, every single chemical reaction, and I mean every one, needs a little push to get going. Scientists call this push activation energy. Think of it like striking a match. That little bit of friction is all it takes to provide the spark needed to start the much, much bigger reaction of the fire itself.
Now, once the dance really gets going, it can go one of two ways. You have exothermic reactions, which release a ton of energy, giving off heat and light, kind of like a roaring bonfire. But then you have endothermic reactions, which do the exact opposite. They actually soak up energy from their surroundings, which is why those instant cold packs you can buy feel so shockingly chilly to the touch.
And here's where it gets really cool. Just like a conductor with an orchestra, we can actually control the rhythm of this dance. We can speed things up by cranking up the temperature, or by packing more dancers onto the floor. That's concentration. Or we can bring in a catalyst, which is kind of like a chemical choreographer. Your body's full of them. They're called enzymes, and they speed up countless reactions every second without getting used up themselves. It's amazing.
All right, we've got our dancers, we've got the energy. Now it's time to look at the different dance moves. Chemists have basically figured out the main choreography, the four main ways that these atoms love to rearrange themselves.
So first, you've got synthesis. That's when two dancers come together to form a bigger partnership. The exact opposite is decomposition, where a big group breaks apart into smaller ones. Then there's displacement, which is basically a chemical game of musical chairs where atoms swap partners. And of course, you've got combustion. That's the super energetic rapid-fire reaction that gives us, well, fire.
Now, I know this might all sound a little bit abstract, like something out of a textbook, but trust me, these reactions are the encore performances happening all around you every single day. So let's bring this down from the atomic stage and right into your world. Just think about your kitchen. It's basically a chemistry lab. Ever slice an apple and watch it turn brown? That's oxidation. The volcano you made in school with baking soda and vinegar? That's a classic acid-base reaction. And that incredible smell when you make caramel from sugar? You're literally witnessing a complex series of chemical breakdowns happening right in the pan.
And this symphony isn't just in the kitchen. It's happening inside of you, right now. The way you digest your food, the process of respiration that turns that food into energy, all of it is just a series of countless, perfectly choreographed biochemical reactions that make your life possible. And if you zoom out, you'll see that we've harnessed these same principles to build our entire modern world. Understanding how these reactions work allows us to create everything from new medicines and stronger materials to generating the power that lights up our cities. It's all chemistry.
You see, understanding this symphony gives us incredible power. And with that power comes a huge responsibility to compose a better future. So, what's next? What does the future of this chemical symphony look like?
Well, chemists are pushing the boundaries every single day. They're trying to choreograph new reactions to develop clean, sustainable energy. They're designing advanced medicines that can target diseases with pinpoint precision, and they're working to find new ways to clean up the environmental impacts from our past.
And really, that's what this is all about. It's about giving you a new lens to see the world through. It's about helping you recognize that whether you're looking at a fizzing bath bomb or up at the stars in the night sky, you are witnessing a constant, intricate, and honestly a beautiful symphony.
So, the next time you see rust forming on a bike, or you watch a cake rise in the oven, I want you to remember the invisible ballet that's taking place. The symphony is always playing, that's for sure. The real question is, now that you can see it, what will you listen for?